Hey, today I'm going to tell you how to write a half reaction from an oxidation reduction reaction. Before we write the half reaction, we actually have to figure out what's being oxidized and what is being reduced. So we have two examples. One is the standard oxidation reduction reaction and another one's a little bit more complicated. But basically what I'm trying to do is show which one is losing electrons, which one is gaining electrons, because the electrons are being switched back and forth between the species. So first things first, identify the elements like I told you before. 0, 0, element, element, element. They all have oxidation states of 0. Now we're going to go through and do any group 1 or group 2 elements. 2 plus. As I look around, there are no other group 1 or group 2. I'm going to identify any oxygens. That is a -2. And now I'm going to go and look at the other components. Now this sulfate, like I told you before, sulfate is, you can treat it like it is one element. And since it is a polyatomic ion, this sulfate is -2. This sulfate is -2. This is aluminum. If you look at the periodic table, aluminum only has one oxidation state, +3. This copper, because it is balanced out evenly with this copper sulfate, is +2. Now I'm going to go through and identify anything that does not change in oxidation. So we're going to eliminate the sulfate. We're not going to pay attention to that. Anything which oxidation does not change, eliminate it altogether. Next step, identify what's being oxidized and what is being reduced. Magnesium goes from 0 to +2. Let's use a better marker. From 0 to +2, that is being oxidized. Over in this one, aluminum goes from 0 to +3. This one is also being oxidized. Now over here we have the oxygen going from 0 to -2. That charge is going down. This one is reduced. Likewise, copper goes from +2 to 0. This one is reduced. Okay, now the step what we need to do is we need to write the half reactions. So I'm going to tell you what is being oxidized and what is being reduced. Get in the habit of writing the oxidation on top and reduction directly underneath it. So in this example, I am going to copy my elements. This is the first rule. Copy the elements exactly as they are written. So for my magnesium, I'm going to write 2Mg. 2Mg is on the left side of the arrow. I'm going to put my arrow in there. And on the right side, I'm going to write down the ions. And I'm going to copy down the ions. I'm not going to use any subscript. So I'm going to put the coefficient in the beginning. I'm going to also add my charge. This one doesn't have a charge, so I don't need to add anything. This one, of course, has the charge. Now I'm going to do my reduction half reaction, which deals with the oxygen. I'm going to copy this element exactly as it's written. Now I'm going to write down this oxygen. But if you pay attention and think distributive property, this coefficient of 2 in front of it refers to the magnesium and the oxygen. So I have to indicate down here at the bottom that I actually have 2 oxygens. So this is 2O with a 2 minus. I know it's a little jumbled in here, but you get the picture. Last step, I want to add electrons to balance out both sides. Here I have a charge of 0 because it's 2 and there's no charge in the magnesium, so 2 times 0 is 0. Here I have a 2 in front and a +2 at the end. 2 times 2 is 4. So I need to balance this out. This is 0, this is +4. I'm going to use the electrons to bring the charges back down together. So if you think of a number line, the plus, so if this is 0, this is +4. I need to use the electrons and bring it back -4, which is 4 electrons. So that's what I'm going to do. I'm going to add the electrons to the side that is more positive. And I'm going to add the electrons the same amount on both sides. But let's just verify. 2 times -2 is -4. So the right half is -4. The left half is 0. I need to make the left half equal to the right half. by using the electrons. So two things you got to do. Oxidation, electrons are always on the right. Reduction, electrons are always on the left. Electrons in oxidation have to equal the electrons in the reduction. All right, whoops. Let's do the next one. Okay, oxidation half reaction. Reduction half reaction. Like I said before, we're going to copy the elements exactly as they're written on the correct side of the arrow. I have aluminum on the left. Over here I have copper. I don't need to write a charge because the charge is 0. It's understood. Now the next thing I'm going to do, and this is a little bit tricky. This is a subscript. I do not want a subscript if it's an ion. So instead of using a subscript, I'm going to use a coefficient instead. The only time you should ever have a subscript if it is a Hofbrinkel. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. So here I'm writing 2Al. I'm also including this charge, which is 3 plus. Now on this side, I'm going to write the same thing. Transfer this down here with the same quantity. Here I have 3 coppers, and I have a +2 charge. Now if I look on the left, on the oxidation half, I have 2 aluminum with a 0 charge, that is the overall charge of 0. On the right side, I have 2 aluminum with the +3 charge. That's an overall charge of 6 electrons to balance that out. Here, 3 coppers, charge of 0. Here, 3 coppers, +2 charge for each one, +2 times 3, +6 electrons. Oxidation, electrons on the right. Reduction, electrons on the left. They are both equal. Don't forget your practice problems.